Hello, my name is Brandon Reeder, and I'm going to talk about how elastic recoil initiates swing in Guinea fowl running. Tendons connect muscle to bone and allow a contracting muscle to move a bone at a joint. Now, tendons are also elastic. You can think about it like an archer drawing a bow. Energy is stored and released. So a contracted muscle will stretch a tendon, release it, and the tendon will rapidly recoil. Now, this amplifies velocity, and power is force times velocity, so you up the velocity, you up the power. Elastic recoil can be found in bipedal locomotion. If you look at the image of the man on the right, during swing, so when his foot leaves the ground, you see that his foot rises. Now this is called dorsiflexion. The muscle responsible for this is the tibialis anterior. Now the man needs to rise his foot in order to prevent tripping. Now the tibialis anterior and elastic recoil has actually been pretty well studied before. However, these studies haven't looked at the critical moment of swing onset, so when the toe leaves the ground, nor have they looked at direct muscle tendon unit forces. Now these two areas we're interested in studying ourselves. We hypothesize that elastic recoil initiates swing. We make two predictions. The first prediction is during mid to late stance, you're going to see the muscle stretch the tendon, yet at swing onset, so when the toe leaves the ground, muscle is going to turn off and the tendon is going to recoil. Our second prediction is that you're going to find greater positive power in the tendon versus the muscle. In other words, the tendon is what's going to be driving dorsiflexion of the foot. To test our hypothesis, we put two guinea fowl on a treadmill. We had them run on it, walk on it, and we inclined it and had them run up it as well. Now, using implanted devices in the bird, we could get live muscle tendon unit power profiles for each trial. For each trial, we see this length change trajectory. So during mid to late stance, we see the muscle is on, it's contracting, and it's stretching the tendon. Now at toe off, so swing onset, we see the muscle turns off and it lengthens. However, the tendon is recoiling. This supports our first prediction. At swing onset when the foot is dorsiflexing, we see greater positive power in the tendon in blue than the muscle in red, meaning the tendon is driving foot dorsiflexion. Some important take-homes. Our data show that elastic recoil initiates and drives foot swing, and quick foot dorsiflexion is important for foot clearance. Now, tendon recoil can play an important part in timing of other locomotive activities. So what's next? Well, we want to investigate the antagonist interaction between the tibialis anterior and the gastrocnemius during locomotion, which means more treadmill experiments, and we also want to investigate the interaction between these two muscles during perturbations to the center of mass, which will call for sliding platform experiments. I would like to thank Shreyas for helping analyze our data set, and Pedro for helping train these birds, and also the staff at Harvard and the Concurrent Field Station for housing and animal care.